Hey everybody, happy Wednesday, April 22nd. It is also Aubrey English's birthday today. She was kind enough to email me to remind me that it is her birthday today. So wish her a happy birthday through email or whatever other ways you want to do. So today we're starting a new unit. So the rest of our kind of science curriculum is all about waves. Okay, thinking waves on the ocean, those kinds of things. What we're going to do is we're going to get some vocabulary words down today, and then we're going to just kind of be rolling through waves. We'll get into sound, we'll get into light. We've got some cool things coming up. So, first thing that we're going to do today is get wave notes down. So, you're watching this video, that'll be right above here once I have done, because I have to have it done to post it. And then we've got wave notes here. Now, how we're going to do notes is we're going to do it like this. So I want you to go into Wave Notes, open it up so that you have it in Google Slides so that it looks just like this. And then what we're going to do is you're going to have this video playing, and I want you to make the video about half here, and then you can click your notes and drag them out. So now you can have the video here. Well, it'll look different for you, but it'll have the video here, and then you'll have the notes here so that you can type the notes while you're still watching the video so that you can put the information in the same place. Now, I don't have to do that since I don't have a video. I'm making it. When I make it a little bit bigger, we've got waves. So we're going to be typing everything that I'm doing, moving everything that I'm doing, finding pictures that I'm doing, all those kinds of things I want you to be with me on. So, essential question today. The thing we're trying to figure out is what are waves? So we know that we've got waves on the ocean. Maybe some of you, I think I've even talked about in class this year, sound waves. We've got light waves. So what are those things? Why do they matter? And how do they work? That's going to be our objective over the next few weeks, is to try and figure out what are waves and how do we do them. So slide number 3, vocabulary. Mr. Kirkwald, everything is all messed up. It's all in a whole bunch of different... I know. Instead of having you go through and type out definitions, I already made them and made them pictures, so that all you have to do is you just have to move them around. So let's do our first definition here of wave. Wave is a disturbance that transfers energy from one place to another. So energy is being transferred through your computer right now. The sound waves are coming out of that. They're traveling through all of the air and then into your eardrum, and your eardrum is making a whole bunch of signals, sending them to your brain, and that's what's happening. So waves are a disturbance of energy that transfer it from one place to another. Now, the material that it travels through we call a medium. So I know that you think of medium like small, medium, large, but when we're talking about waves, a medium, or when we're using medium in science, medium is, oh, whoops, that's not the, is the material through which a wave travels. So a medium is the material through which a wave travels. So ocean waves travel through water, sound waves can travel through air, those kinds of things, that's a medium. Now, we have 2 other vocabulary words here, which I'm really disappointed that we couldn't be together for this one, because both of these ones I really like to have kids try and say if they can, because they're a little bit longer words that you probably haven't heard of before, and it's always just interesting to see how you guys can say them. So, our first word is transverse waves. And transverse waves, those there. A transverse wave is the movement up and down as the wave passes through it. So we have an upward and a downward motion as the wave is moving. So an ocean wave moves up and down and up and down. And then we have a longitudinal wave. This one is a little bit more complex, and that's why we're going to do pictures in a minute. A longitudinal wave is where particles move back and forth in the same direction the wave travels, or parallel to the wave. So we have transverse waves and longitudinal waves. So let's, on slide 4, find some pictures together. So I'm going to go Insert, Image, Search the Web, and I already did this. So I'm transverse waves here. So typed in transverse waves, and this is what a transverse wave looks like. And I'm even going to grab this one because it's cheating. and it has a whole bunch of words that we're going to need later. So I'm going to grab, there we go, a transverse wave here. So we can see it actually moves up, down, up, down. Think ocean wave when you think of transverse wave, okay? A longitudinal wave, though, is more like a spring moving through it. And let me see if, well, this one, well, let's do this one here. It doesn't work. Okay. A longitudinal wave, let's do a different one. A longitudinal wave is actually more like this one here. So in this image, you can see that the particles are clumped together and then more spread out, clumped together, spread out. It's kind of like an accordion, right? Where everything gets clumped together and then spreads out. Or if you like push a slinky, you'll see that it gets clumped together, spreads out, and that's a longitudinal wave. So longitudinal waves don't move up and down; they move in a straight line, but that energy gets kind of bunched up and then goes further apart, bunched up, further apart. So transverse waves up and down, longitudinal waves clumped apart, clumped apart. So characteristics of those waves. So a transverse wave is actually a light kind of wave, okay? And longitudinal waves are sound waves. So when we think of light waves, we can think of a rope moving up and down, okay? When we think of longitudinal waves, those use compression and stretching to move that energy. So like an earthquake would be a longitudinal wave, where it's actually compressing the earth and moving it back and forth. It's not actual waves happening on an earthquake. It doesn't look like an ocean when that's happening, okay? And then we've got two types of waves. So when we're talking about, I know this is a lot of information for one day, but this will kind of get us to where we need to be. So we have transverse waves and longitudinal waves, up and down, okay? And then we also have the compression, decompression ones. We've got two types of waves here as well. We've got electromagnetic waves and we've got mechanical waves. So a mechanical wave is a wave that requires a medium. Here, I'll just straighten out first. There we go. A mechanical wave is a wave that requires a medium to travel through. So if you remember, a medium is an actual material. So a mechanical wave needs a medium. It needs something to travel through. Okay? Sound waves are mechanical waves because they need a medium to travel through. If you were to yell in space, well, if you didn't have a spacesuit on and you yelled in space, nothing would happen because there's no molecules to be pushed on for that sound to travel. However, electromagnetic waves, we'll abbreviate that in the future, but electromagnetic waves are a disturbance in the electric and magnetic fields, and those do not require a medium. So light waves are electromagnetic waves. They don't require a medium. Light can travel through space. So that's why we can see the sun. It's because these light waves can travel without anything. They don't need air to travel through. They can just go straight through the nothingness of outer space. Okay? So we've already talked about a couple of these types, and now I'm on slide 7. So we've got a mechanical wave. So sound waves are mechanical waves. Water waves are mechanical waves. Earthquakes are mechanical waves. Without the earth, you can't have an earthquake. Without water, you can't have a water wave. Without air, you can't have a sound wave. So then electromagnetic waves, though, we've got visible light, which we know of. The radio waves, so the waves that are coming into your car when you're listening to the radio, those waves do not require a medium. So actually, as they're traveling through the satellite and coming down to you, they're actually going into space too, and they're still moving. So so that KDWB song that you're hearing on the radio, that's actually traveling out into space and it's still going. And so if aliens are out there and they can hear that, they would be able to hear whatever song that's being played on the radio. And they might think of us differently because of it. Hopefully, they're listening to the classical music station. And then microwaves, not the actual like microwave oven that you have in your kitchen. That is an actual thing. But the waves inside of it that heat up your food are called microwaves. That's why it's called a microwave oven. And those waves can travel through nothing as well. They're electromagnetic waves. So, in summary today, you can type this up. Waves are disturbances that transfer or move energy. They can either be transverse and go up and down, or they can be longitudinal and be compression and then that decompression. And so you can pause the video and type that up. I want to show you one more thing to help with transverse and here we go. Transverse versus longitudinal. So here's the best one that I could find. So we've got transverse waves. We can see it moving up and down, transverse wave. Longitudinal though, watch the red line, boom, and it's traveling through. So same thing with a slinky. You can move a slinky up and down, but if you actually push a slinky, you can actually see that compression go through the entire wave. So this should give you a little bit better explanation of what a transverse wave is versus a longitudinal wave. So hopefully notes went okay. It says 11 minutes here. I'm sure with pausing and doing things like that, it may have taken you a little bit longer, but that's really all we needed to do today. And then tomorrow we have a reading assignment, and then this one is going to be going back to our notes. That's why it's empty here. So I'll make a little video there so that way you know to go back to your notes there. And we're going to fill in some more slides. So if you have any questions or if something was super confusing, feel free to email me. We can get a Google Meet going, or we can just kind of talk through email, whatever we need to do. But hopefully we know a little bit more about waves now, and then you can go and enjoy doing some other work. Thanks, guys. Bye.